All right, we are going to write an algorithm that will rotate a linked list counterclockwise by k nodes. So say we had 1, 2, 3, 4, and 5, and say k equals 3, then we would want to rotate it so that we would have 4, 5, 1, 2, and 3 as our new linked list. So rotating after the 3, that's k, then we're rotating those last elements that are left. Okay, so to do that, we need to keep track of a few things. We have our head here. This is null. And what we want to do is have a starting pointer. So our start. And what it needs to do is basically pop the number that's k. So if k equals 3, then we need to move start to this position. And we need to mark the next one as kind of our new head so that we can reassign head to this head as we rotated. So first we mark new head, then we can set this next pointer to null, and then we can have like a rotate pointer. And while rotate.next is not null, we just move it. And so it would move to the 5, and then the next is null, so it would stay here at 5. And then what we need to do is set 5's next, or rotates.next to head. And then we can move head to the new head. So new head will just become head. It was previously, it still is new head, but yeah, now we also have our head at 4. So what we've ended up with is 4, 5, 1, 2, and 3 all linked together. 3 is definitely pointing to null next, and 4 has the head. So we're just where we want to be. Okay, so to code this, we can start out where we're going to get a we can go ahead and return the new head node. I'll just call it rotate, and it's going to receive a head. And we should probably define our nodes first. Okay, we can make it generic. Got some sort of data, and then it has our next node. Okay, and then our linked list. And it just has a node of data. Not data, it's a head. Sorry about that. Node head. Okay, and so we get our head node. We can define this as like ints or something. It doesn't really matter. Okay, and then the first thing we need to do is let's make sure that our head isn't already null. If head is null, then we can just return head, or we could throw an exception, you know, something like that. And then otherwise, we'll get into our algorithm. And so we need a start. And that's going to start at the head. And then we need, we'll eventually need a new head. And well, we'll assign that in a bit. Okay. And then let's see. So first we need to do while, or let's just do a for loop. So for int I equals, we can start it at 1, just so conceptually it's easier to think about. And I is less than k. Oh, so that's the other thing we're going to need. We're going to need to know k sent in. Okay, I is less than k, I plus plus. And then while we do all that, so then start equals start dot next. Okay, and then after we do that, then it's time to go ahead and we can set our new head equal to start dot next. And then we also have a rotate node that will start. We'll have a rotate node. And that will also start at start dot next. Okay, and then so while, well, first, now that we've done that, we can say start dot next equals null. So we've disconnected that, and then while rotate dot next does not equal null, rotate equals rotate dot next. And then after we've gone through that, then we know that we need to set rotate dot next equal to head. And then we can set to, that's some extra stuff on here we need to erase. Okay. Okay, then we can set head equal to new head. And let's look at our picture. That should do it. So head is going to equal new head. Rotate dot next is going to equal the old head. Okay, so that should take care of it. So let's go ahead and walk through the code. And actually, we can finish this and return our head to finish it off. Okay, so let's go ahead and get an example going. Okay, that's null. And here's our head. Okay, so let's say k equals 4. All right, so we go in, k is 4, we've got our head is not null. So node start equals head, so we've got start here. Okay, I starts at 1, and I is less than k, so let's go ahead and keep track of I. So I is at 1, start equals start dot next, I plus plus, 2 is less than 4, so start equals start dot next, I plus plus, 3 is less than 4, so start equals start dot next. So we're kind of here with start, I plus plus, 4 is not less than 4, so we go ahead and we get out of that for loop. And then we go node nh equals start dot next. So start dot next is there. So that's nh. And then node rotate also is going to start here. Now that we've captured that, start dot next equals null. So then this breaks off and becomes null. So while rotate dot next does not equal null, rotate equals rotate dot next. So rotate is now here, and then the next is not null, so it goes to here, and then the next is null, so we stop our while loop, and rotate dot next equals head. Okay, so rotate dot next, this is rotate here, so instead of being null, it's going to go over here to our head, and then head equals nh. So this is now the head. And then we're going to return the head. So what we ended up with is returning this node that then has 6, 7, 1, 2, 3, and 4. And this is null. Okay, so that looks about right. We've got 1, 2, 3, 4 is our k, and that is all here. And then we rotated 5, 6, and 7. And this is a linear solution. We only have to go through the number of nodes n times. So we're O of n in time complexity, and we didn't use any additional space.